Okay, in this example, it's telling us that our function is 5x to the third, and they want us to find the derivative of the inverse when x is 40. Let's do it the long way. Normally, we're going to find the derivative of the inverse without even finding the inverse function. We have an easy rule that we use, but let's do it the long way. Let's find the inverse, and then let's do the derivative of the inverse, and then let's plug in 40. Let's say y equals 5x to the third. Now I realize this is called f, but I'm just going to use y, and I'll change it back to f later. Now to find the inverse, we have to switch the x and the y, and then we have to solve for y. Now normally I would just call this y inverse because I'm done, but remember the original name was f, so I'm going to call this f inverse. So now that we have f inverse, we can do the derivative of f inverse, and then we'll plug in 40. Okay, before I do the derivative of the inverse, I want to rewrite it as a power of 1/3. Okay, now we can do the derivative. The 1/3 would come down. The new power would be 1 less. And because the inside was not just an x, it's an x over 5, so we're going to have to do the derivative of x over 5, and that would give us a 1/5. So the 1/5 is basically the chain rule. Now we can rewrite this. A negative 2/3 power on top would become a positive 2/3 power on the bottom. Remember, the thirds is the root, so we have third root. And if you look back at the original question, we had to find the derivative of the inverse when x is 40. This is the derivative of the inverse for any value of x. So we want to plug in 40. Okay, let's simplify this. 40 over 5 gives you 8. The third root of 8 is 2. 2 squared is 4. And 15 times 4 gives you 60. Okay, that was a lot of work, but we got that the derivative of f inverse when x is 40 equals 1 over 60. Now at this point you got to be thinking, man, there's got to be a better way. And yes, there is. Okay, we're going to do the exact same problem, but we're going to use the rule for the derivative of the inverse. Remember, in our previous example, we did it the long way, and we got 1 over 60 for our final answer. Now here it says the rule for the derivative of the inverse is just going to be 1 over f prime. So here's f. 1 over f prime would be 1 over the derivative of 5x to the third. Okay, this would give us 1 over 15x squared. Now here's the only tricky part of it. We want the derivative of the inverse when x is 40, but that x belongs to the inverse. Let's take a look at what that means. For a regular point, we'll call it xy, the corresponding inverse point is going to be the opposite. It's kind of like yx. So this 40 is the x value for f inverse, just like you see right here, but that means it would really be the y value for the original f function. So we cannot plug in a 40 here for the x value because the 40 is actually the y value for the original function. What we need to plug in right here is the x value for the original function. So we have to figure out when y equals 40, what is the x value? Because that's the x value that goes here. Okay, because they gave us the original function, we could plug a 40 for the y value and figure out what the x would be. Divide both sides by 5. Cancel the 5. Take the third root of both sides. So we get x is 2. So that's the value we want to plug in over here. So our final answer is 1 over 15 times 2 squared. So we get 1 over 60. And that's a much faster way of finding the derivative of the inverse when x is 40. Okay, now let's do a bunch of these examples. Here's our function. We want to find the derivative of the inverse when x is 5. So we can start with 1 over, and then we'll do our f prime on the bottom. Now remember, you cannot plug a 5 for the x. And the reason why is because that might be the x for the inverse, but it's actually the y for the original function. So the 5 is actually the y. So I'll trade the y for 5. And then we can figure out what the x is supposed to be. We'll add 995 to both sides. We do the third root of both sides. We find out that x is going to equal 10. So the 10 is the x value for the original function, so we want to plug a 10 for the x. Final answer. Get 1 over 300. Okay, this is a bit of a tricky example, because if you look at the actual function, you might notice that it's not a one-to-one function, and that's because it does not pass the horizontal line test. You see it crosses more than once. So this function, as we see it, does not have an inverse. So you'll notice that we have to do this restriction where it says that x is less than or equal to 1. So that means we're just looking at the left side of it. Again, we can use our rule for the derivative of the inverse. It would just be 1 over, and then we just do the derivative of this on the bottom. Now this function is just going to be x squared minus 2x minus 8. And if we do the derivative of that, we would get 2x minus 2. Again, we cannot plug this 0 for the x, because that 0 is the x for the inverse, but it's actually the y for the original function. So if it's the y for the original function, then we can just plug it in for the y on the original function. Now this is where it gets a little bit tricky, because you can see that we get two answers. We get 4 and we get negative 2. Now you can either look at the graph, or you can look at this restriction here. It says that x has to be less than or equal to 1. So we can just throw away this 4. The only solution possible is negative 2. So we're going to plug in a negative 2 down here. And you can see our final answer is just going to be negative 1/6. Okay, here's another example where they want us to find the derivative of the inverse when x is 7. But you'll notice they don't actually give you the function. Now if we just use the formula, we know our answer is just going to be 1 over f prime of x. Now it does give us 3 different solutions for f prime of x at different values of x. So the only thing we have to figure out is what is that value of x that I'm supposed to use. You notice it gives us a couple points right here. So this tells us that for the f function, when you plug in a 7, you get 5. Also for the f function, when you plug in a 3, you get 7. Now for the inverse, we're just going to switch the order. So we know for the inverse, when you plug in a 5, you get 7. And for the inverse, when you plug in a 7, you get 3. Now up here, you'll notice that the 7 is the x value for the inverse. So that corresponds to this point. This point has an x value of 7. So that means it would have a y value of 3. And so that's the point we want to use. That corresponds to this point that has an x value of 3. So we want our x value right here to be 3. So our final answer is 1 over f prime of 3. It tells us what f prime of 3 is. It's 8. So our final answer is going to be 1 over 8. Okay, for this example, it's telling us that g is the inverse of f. Well, at this point, that's too many letters. We're going to start to get confused. So let's just rewrite this g as f inverse. Okay, so this piece right here is going to be f inverse. You'll notice there is a prime, so that means the derivative. So I'm going to put the derivative in front of this. You'll also notice that there's a 7, so that means when x is 7, but that x value of 7 belongs to the inverse. So for the original function, it would really be a y value of 7. Now this problem is actually a little bit easier than normal because we can see an x value of 7 right here. So this point tells us that for g, we have 7 comma 5. Remember, that's f inverse, 7 comma 5. So then for f, we would have 5 comma 7. So again, we're trying to find the derivative of the inverse. So it's just going to be 1 over f prime. But again, the x value that we're looking for is going to be 5. So this is 1 over f prime of 5. So our final answer is going to be 1 over 11. For this example, we're going to use a table. That's a common thing that you would see on the AP test. So here it says, what point would you use to write the equation of a tangent line to the graph of y equals f inverse of x at x value of 1? Okay, so this x value of 1 belongs to the inverse. But notice we want the tangent to be on the graph of the inverse. So we're going to stick with this x value of 1 that they're telling us. We already have the x value. It's going to be 1 comma something. We do have a couple points over here that we can look at. For f, we know that when x is 1, the y is 5. We also know that when f is 3, the y is 1. So for f inverse, that tells us that when x is 5, y is 1. And for f inverse, when x is 1, y is 3. Just switch the order of the x and the y. So what point would you use? Well, we know we need the point when x is 1, and the point is on the inverse. So this is the point we're looking for. This point belongs to f inverse, and when x is 1, you're getting a y value of 3. So because we're just looking for the point, that's the point 1 comma 3. Okay, here's our last example. They give us a table of values, and we have to find h of 1, and then later we'll find h prime of 1. All right, so if this is h of x, then h of 1 is going to be f of g of 1. Okay, first we need to figure out what is g of 1. So when x is 1, the g value is 3. So we can plug in a 3 down here. So h of 1 is f of 3. What is f of 3? Here are your f values, and here are your values when x is 3. You can see they intersect here. So f of 3 is 5. Okay, our final answer is that h of 1 is going to be 5. Okay, this is a 3-part question. Part 1 was over here. The second part is find h prime of 1. So we're going to start by finding h prime of x. So here's h of x. So h prime of x is going to be f prime of g. Now I think you can see this is going to need the chain rule because that's a g and not just an x. We need to multiply by the derivative of g. Then we can plug in the 1. And we're going to have to look at the table to find g of 1. G of 1 is 3. And we're going to have to look at the table to find g prime of 1. G prime of 1 is 5. And lastly, we need to find f prime of 3 from the table. F prime of 3 gives us 7. So final answer is 7 times 5, and that is 35. Again, we're going to use our answer from part 1 and part 2 in order to answer part 3. Okay, remember h of 1 is 5, so that means for h inverse, you get the 0.51. Also, h prime of 1 is equal to 35. Now we're going to use that information to find the derivative of the inverse when x is 5. We already know the derivative of the inverse is just going to be 1 over h prime of x. The problem is, what value of x do we use? Let's take a closer look. This x value belongs to the inverse, so the 5 would actually be the y value for the original function. So the x value from the original function is really going to be a 1. So the answer for the derivative of h inverse when x is 5 is 1 over h prime of 1. We already figured out what h prime of 1 is 35. So your final answer is 1 over 35.